Today, we are undertaking a really critical strategic deep dive. We've gotten our hands on this massive strategic blueprint, a roadmap from a major consultancy,
Right.
and it details the future of the digital and intelligent supply chain, specifically for automotive hardware, mapping a path all the way out to 2040.
And this isn't just another forecast. You have to understand, this is a detailed, multi-decade plan for the total reconstruction of a global industry.
A reconstruction that you've said is absolutely necessary.
Oh, it's completely necessary. The whole context has shifted. For decades, the auto supply chain was all about one thing: efficiency, cost reduction.
Just in time.
Perfecting the just-in-time model, exactly. But now, as this report points out very clearly, the industry is navigating what they call a century-scale profound transformation.
A century-scale transformation.
Yeah. And the complexity of the new car, you're talking high compute chips, advanced sensors, specialized power management, massive battery systems. It all demands that the supply chain evolves. It can't just be a functional cost center anymore. It has to become a strategic, intelligent organism.
So our mission today is to give you that strategic shortcut. We're going to synthesize this incredibly dense material into actionable knowledge. We'll start by unpacking the core definition, what D&ISH, the digital and intelligent supply chain, even is. Then we'll analyze the current global competitive landscape. How do the established ecosystems stack up against the newer, fast iterating ones?
And that's a fascinating contrast.
From there, we'll detail the 4 strategic pillars that define this whole overhaul. And then, and this is the critical part, we'll map out the specific, quantifiable technological milestones, the actual KPIs that measure success all the way to 2040.
Let's nail down that definition first, because you're right, it's important. D&ISH is so much more than just putting computers in factories.
Yeah.
It's about the collaborative application of advanced digital and intelligent technology.
Things like AI, digital twins, blockchain.
Exactly. And it's applied by automakers and their hardware suppliers across the entire product lifecycle. Everything. From the initial start of an idea in R&D, through procurement, physical production, dynamic logistics, all the way to after-sales service, and even material recycling at the end of life. It's genuinely full spectrum.
And what immediately jumped out at me, right on page 1, is how this roadmap changes the very nature of collaboration. It's a fundamental shift away from what the report calls transactional cooperation.
The legacy model.
The legacy model, exactly, where a huge OEM basically dictates terms, and all the upstream suppliers just compete with each other on price and delivery for a part that's already been designed.
Well, that linear, rigid chain is collapsing. It's just buckling under the weight of all this new complexity. The future demands what the report labels co-creation.
Co-creation?
Yeah. This means all the partners in the ecosystem are engaging in shared technology research. They're jointly assessing and managing risk, whether it's geopolitical or technical, and then they share in the value that's created.
So the structure itself has to change.
It has to. It's morphing from that old OEM-led linear chain into a networked, interwoven ecosystem built on multi-industry fusion. You should think of it less like a chain of command and much more like a dynamic web of shared capability.
That dynamic web feels essential because the real innovation in the new car, it seems to happen at the intersection of industries, right? Automotive meets semiconductors, meets consumer electronics, meets energy storage.
You can't dictate that kind of synergy from the top down. You have to foster it through these shared platforms. It's the only way.
Okay, so let's really unpack this transformation. Let's look at the management philosophy that's driving it. If the supply chain's DNA is being, as you said, reconstructed, what is the core, fundamental change in its operational capability that this 20-year roadmap is trying to achieve?
The consultants frame that core goal as a thorough reconstruction of the supply chain's capability DNA. And I like that phrasing because this isn't just an upgrade or an optimization. It's a genetic reassembly.
A reassembly.
It is. And it's designed to instill 2 primary and I'd say inseparable strategic goals into the very fabric of the system.
Okay, so what are those new genes?
The first one is resilience. This is the defensive backbone. This is what the system absolutely needs to survive now. It has to be able to form a structure capable of rapid, almost instantaneous response to massive external shocks.
We're talking about things like geopolitical risk, natural disaster.
Or the extreme supply and demand volatility that we all witnessed. The chip shortage was a catastrophe that brought the industry to its knees. If the supply chain fails on resilience, the entire organization just stops, dead in its tracks.
Which is so much more critical now because, as we've noted, the hardware in these new cars is far more sensitive and complex. I mean, the lack of a single $5 chip can halt the production of a $60,000 vehicle.
That is the perfect example. So that's the first gene, resilience. The second goal is wisdom and synergy. This is the internal revolution. This is about moving the system away from what the report calls experience-driven crude management.
Which is what? Relying on gut feelings and spreadsheets?
Basically, relying on tribal knowledge, spreadsheets, basic forecasts, the way things have always been done. The goal is to shift to data-driven, intelligent operation. The ultimate purpose of this is to use AI and connectivity to fundamentally improve industry-wide efficiency, effectiveness, and, this is key, the capacity for continuous autonomous innovation.
So it's about being smart, not just fast or tough.
Exactly. Smart, not just fast.
So to achieve both resilience and wisdom, the whole strategy is built around four major interconnected pillars. These seem to form the architectural foundation for the entire D&ISH roadmap.
They do. They define the entire transformation journey through 2040. The first is the supply chain ecosystem, hardware. This is all about governance. It's about building that open, cross-industry, highly cooperative network we discussed, and making sure the legal and data frameworks are in place to allow for deep, secure sharing.
Okay, so that's the who and how of collaboration. What's next?
Second is collaborative R&D innovation. This one is all about getting efficient with resources, sharing IP, and critically, ensuring hardware design becomes modular and truly adapted for software definition. It's about reversing the traditional R&D sequence where hardware comes first, locked in for years.
The third pillar, intelligent supply, that sounds like it deals with the physical world.
It does. It's about creating an integrated system covering real-time demand response, full process monitoring, accurate delivery, and even initial after-sales service. This is where, automation meets real intelligence, the factory floor and the logistics network.
And the fourth pillar is the one that powers all the others.
It's the central nervous system, the underlying engine, AI empowerment. This is the core technology that drives that philosophical shift from mere digitalization.
Which is just turning paper processes into digital ones.
Right. It's a simple conversion. This is about moving from that to true intelligent self-evolution, where the system learns, adapts, and improves on its own.
And to show just how comprehensive this strategy is, the roadmap breaks it down into 10 specific, high-level practical scenarios that these four pillars are meant to revolutionize.
Yeah, these are the functional areas that will look drastically different by 2040. You can almost group them by the pillars.
Right. So under ecosystem, you're trying to solve the cooperative integration model and digital platform operation.
Exactly. Then under R&D, you're focusing on user demand insight, R&D resource sharing, and that really crucial one, hardware-software collaborative design.
And then the execution piece under intelligent supply that covers things like flexible and agile manufacturing, full process online sensing, which is really about transparency, full chain accurate delivery, and collaborative after-sales service.
And then finally, tying all 10 of those together is the ultimate goal, which falls directly under AI empowerment. Intelligent decision-making and self-evolution. This is the final step. It's the creation of that single, cohesive, self-optimizing organism we talked about. This roadmap, it demands not just new tools, but a completely new operating system for the entire value chain.
Understanding the starting line is so essential for appreciating the strategic scale of this roadmap. The report gives us this really sharp contrast between what it calls the domestic and international ecosystems. It's an essential baseline. So where does the industry stand globally right now across those four dimensions?
Let's start with ecosystem and structure. And just to clarify, when the report discusses domestic versus international, it's primarily benchmarking the rapidly evolving new energy vehicle or NEV-focused supply chains in China against the established legacy systems you'd find in North America, Europe, and Japan.
Okay, that's a very important distinction.
It is. Internationally, the structure is mature, it's highly standardized, and resource sharing is well established, especially for critical high-volume components. They have very professional, very robust systems for global risk management.
But the report also suggests that those international systems, while mature, are often, well, hampered by legacy factors. Things like traditional cooperation barriers, strict proprietary patents, siloed data systems that limit data sharing.
They're standardized, but they can be slow and rigid. That's the crucial dynamic here. The domestic ecosystem, on the other hand, while it may be less standardized overall, shows significantly higher flexibility and openness. And that's driven by rapid policy mandates and just raw market speed.
And the report highlights a key example there, right?
It does. It highlights the preliminary success in building a full life cycle ecosystem for power batteries. This includes everything from localized raw material mining and refining, all the way to manufacturing, logistics, and even recycling. It's a closed loop.
That kind of vertical integration in power batteries is a massive strategic advantage for resilience, isn't it? It means you're far less exposed to the volatility of global raw material prices, which, as we've seen, can destabilize entire economies.
Absolutely. So you have this contrast. The foreign systems lead in established data gathering and professional risk management, but the domestic model is much more agile because of its openness and speed. It just needs to improve its core standardization across the network.
Okay, let's move to the second dimension, collaborative R&D evolution.
Right. Internationally, innovation relies very heavily on these established modular vehicle platforms. Think of Volkswagen's NQB or MEB platforms or Toyota's TNGA. They also rely on mature proprietary cloud platforms like Siemens Teamcenter. And they accelerate innovation by acquiring startups through their internal VC arms, like BMW iVentures.
A very structured, traditional approach to innovation.
Very. Domestically, the R&D evolution is, again, heavily policy-guided. It's driven by this intense focus on NED leadership, deep user participation, and the entry of tech giants. The report gives the excellent example of the Huawei Inside, or HI, model. And what does that model do differently? Huawei leverages its deep expertise in information and communications technology, their ICT capabilities, to create a single digital platform for concurrent development. So you have vehicle firms, software developers, and hardware makers all working simultaneously on the same platform. This approach just significantly compresses the R&D cycle by breaking down all those traditional design silos. That speed of concurrent development sounds like a major competitive differentiator. It directly challenges the platform maturity of the legacy players. It is. It's a huge challenge. The third dynamic is resilience and flexibility. And this is where you see the lessons learned during the recent global crises. COVID, the Suez blockage, the chip shortages, they forced a radical philosophical shift across the board.
Away from zero inventory.
The old, strict, zero-inventory just-in-time model, which was perfected over decades, is now seen as a major liability. It maximizes efficiency, sure, but it does so at the expense of survivability.
The strategic trade-off is crystal clear. Efficiency is being traded for strategic redundancy.
Precisely. The new strategy involves establishing what the report calls a moderate safety stock for critical strategic items.
Things like high compute chips or rare earth materials.
Exactly. You build a buffer for short-term shocks. Now, domestically, this shift is reinforced by a national chain leader system, which is policy-driven coordination, and also by massive investment in domestic substitution for critical automotive components.
And to clarify for our listeners, when we say critical components, we're talking about the brains of the vehicle, things like systems on chip or SOCs.
Right, and also microcontroller units, MCUs, which handle all the smaller distributed control tasks, and then specialized power management chips like IGBTs, which are absolutely essential for controlling the high-power battery systems in electric vehicles.
That context is vital. But the report highlights that even with all these advancements, there's a shared, persistent global weakness.
Yes, the bullwhip effect.
Hey, explain that for us.
It's the phenomenon where small, minor changes in an OEM's demand plan get amplified dramatically as they travel down the supply chain to Tier 2 and Tier 3 suppliers. A small ripple becomes a tidal wave.
It's just fascinating that even with all this new technology and digital visibility, that basic human problem of coordinating demand down a long chain still persists.
It does. It shows the limits of digitalization without true intelligence. This lack of deep real-time coordination means suppliers are often reacting to outdated forecasts, which severely limits the overall flexibility of the entire system.
Okay, finally, let's look at the fourth area, AI application.
Internationally, the focus remains on deep technical breakthrough. This includes controlling the foundational frameworks like Google's TensorFlow or Meta's PyTorch, and maintaining leadership in key AI hardware through companies like NVIDIA. They also dedicate a lot of resources to navigating the ethical and regulatory debate around autonomous AI.
And the domestic approach, in contrast, seems to be heavily application first.
Yes, it's driven by policy and these big tech giants. The domestic ecosystem prioritizes rapid application scenario rollout. Innovation is primarily concentrated in the application layer, getting AI into practical use cases as fast as possible.
Like intelligent prediction for logistics or automated quality control on the factory floor.
Exactly. But the report is very candid here. It identifies a recognized strategic gap in foundational algorithms and system architecture when compared to the foreign leaders. So it's this really interesting contrast between maximizing application speed versus controlling the foundational science.
All right, this is where we move from strategic analysis to concrete action. The report defines success with clear, measurable metrics leading all the way up to 2040. This isn't just buzzwords, it's a very specific pathway. So, what is the ultimate 2040 vision, and how do they plan to measure progress along the way?
The ultimate 2040 vision is, well, it's extremely ambitious. It frankly sounds like something out of science fiction. The report frames it as a man-machine, interconnected, globally visible, multi-party collaborative, co-creation, self-evolving ecosystem centered on automotive hardware.
That's a mouthful.
It is. But the key idea is that it's envisioned as a living, networked, intelligent entity that is constantly learning and optimizing itself.
And to gauge the progress toward creating this entity, the report uses something called the iMsH maturity model. Let's remind everyone, iMsH stands for Intelligent Manufacturing for Supply Chain Hardware. And this model defines 4 progressive levels of maturity.
That's right. You move from iMsH level 1, which is just basic digitalization and single-level collaboration, all the way up to iMsH level 4, which is that ultimate ecological co-creation system. And the roadmap outlines the expected percentage of companies that need to reach each level at 3 distinct milestones.
Okay, let's start with the 2030 near-term goal. This is focused on getting the foundation's right data and synergy.
By 2030, the goal is modest but foundational. 40% of companies must achieve iMsH 1. That means they have the basic digital tools and visibility within their immediate partnerships. A solid 50% need to reach iMsH 2, which is multi-level network collaboration. This is where data is automatically collected and shared across multiple tiers of partners.
So that enables some initial intelligent decision support.
Right, and only about 10% are expected to hit iMsH 3. So this shows that by 2030, the vast majority of the industry is still just focused on mastering the basics of digital data flow.
Okay, so then by 2035, we hit this critical acceleration phase. This must be where the real integration takes hold.
It is. This phase is all about advanced integration. By 2035, the majority shifts. 50% of companies should now be operating at that iMsH 2 level, fully entrenched in network collaboration. But the real change is at the top. 40% have to achieve iMsH 3, showing they've mastered full chain intelligence and dynamic control.
And crucially,
10% are expected to hit the ultimate iMsH 4, the ecological co-creation system. That initial 10% is the leading edge, the proof of concept that proves the viability of this whole self-evolving supply chain model.
and then we get to 2040, the long-term tipping point, where the vision becomes reality.
The 2040 targets show a complete structural overhaul. The lower tier category, iMsH 2, shrinks dramatically to just 5% of companies. The new standard of excellence becomes iMsH 3, which has to encompass 50% of the industry. But the ultimate strategic goal is for 45% of the industry to achieve iMsH 4.
45%, so nearly half the entire automotive hardware ecosystem will be a mature, self-learning, self-deciding entity governed by multi-intelligent agents.
That's the vision.
Those maturity levels describe the quality of the system, but the report also gives us hard, measurable, key performance indicators, the KPIs measured against a 2024 baseline. Let's look at the sheer magnitude of the efficiency gains they're expecting by 2040.
The targets are staggering, and they're driven purely by this integration of AI and digital platforms. So for collaborative R&D innovation, the cost reduction targets are aggressive. By 2035, they're targeting a 30% reduction. The final 2040 target is a 40% decrease in R&D cost compared to 2024 levels.
A 40% cost reduction over just 16 years is transformative for corporate profitability. I mean, that frees up massive amounts of capital to be reinvested into next-generation innovation. It creates a continuous feedback loop.
A powerful one, absolutely. At the same time, under the intelligent supply pillar, resource coordination efficiency is targeted to increase by 40% by 2035 and then reach an astounding 70% increase by 2040.
And that's measuring how well shared resources are allocated.
Yes. Things like manufacturing capacity, strategic raw materials, computing power, how well they're allocated and managed across the entire ecosystem. That's nearly a doubling of operational effectiveness.
And the predictive power of this new ecosystem is maybe the most important measure of wisdom.
It has to be. The intelligent prediction accuracy must increase by 50% by 2035 and then accelerate to an 80% increase by 2040. This means the system will almost double its ability to accurately foresee future supply and demand states, potential quality defects, logistics bottlenecks, all using advanced AI models. It's a cornerstone of moving from being reactive to proactive.
Finally, let's look at the critical measure of the system's defensive capability, its resilience.
Right. The full chain emergency pull-down rate. This is basically the time it takes for the entire network to either stop a catastrophic interruption from spreading or to recover from a shock. That is targeted to decrease by 25% by 2035 and reach a very significant 35% decrease by 2040. This reflects the successful embedding of that resilience DNA we talked about.
And as we said, AI is the engine for all of this. How does the report map the specific role of AI as it transitions across the decades?
It charts it in 3 distinct phases. In 2030, AI is basically an assistant. It's for preliminary digitalization and filling in the gaps. It tackles the specific, fine-grained, or long-cycle decisions that humans are just not good at, like optimizing a complex factory schedule. It's an intelligent tool that offers advice.
Okay, so it's a co-pilot.
A co-pilot. Then, by 2035, AI assumes the role of the main force across the entire supply chain. Human operators are strategically relegated to handling only the urgent, sudden emergency decisions that the AI models haven't been trained to address yet.
So AI becomes the default operating system by the midterm.
Precisely. And by 2040, data-driven intelligent decision-making is fully established. The source calls this all-chain collaborative intelligent decision-making. The system is essentially running itself. It's autonomously optimizing, iterating, and managing exceptions in real time. It's the fulfillment of that iMsH 4 promise.
If the supply chain's DNA is being reconstructed for resilience and wisdom, the most crucial place to start that transformation has to be at the very beginning in collaborative R&D innovation. How does a hardware supplier go from being a passive responder to an active co-creator in this age of software-defined vehicles?
Well, it starts with the customer.
Yeah.
It's about moving R&D from internal speculation to what the report calls user demand insight, which is rooted in deep, heterogeneous data. Traditionally, R&D relied on static market reports and focus groups. The future demands a direct, dynamic connection between the vehicle's real-world operating data and the design supply chain.
So you're saying we're integrating app feedback, charging behavior data, even how people interact with the intelligent cockpit, directly back to the engineers who are designing the next generation of semiconductors.
Yes, and much, much more. By 2030, this means collecting massive amounts of this heterogeneous data, the big data of the car, and running virtualization and dynamic scenario simulations to verify component feasibility before the first physical prototype is even built.
And by 2040,
By 2040, this evolves into highly advanced cross-industry ecological research using futuristic tools like industrial metaverse technology.
industrial metaverse technology for automotive R&D, that sounds like a massive step change. How do they actually envision that working in practice?
It's about collaboratively researching entirely new scenarios that go beyond the vehicle itself. You're essentially using a virtual environment as a shared R&D laboratory. The sources cite examples like using the metaverse to simulate and perfect human-vehicle interaction with, say, urban service robots,
Okay.
or conducting car plus aviation intelligent interaction scenarios to coordinate with drone transport. The supply chain has to start innovating demand itself, not just passively responding to the automaker's next spec sheet.
That brings us to R&D resource sharing. If everything is collaborative and cross-industry, how on earth do you manage shared assets, intellectual property, computing power? How do you do that across rival companies without massive trust and legal issues?
This is where advanced decentralized technology creates the framework for that trust. By 2030, the focus is on establishing shared digital platforms that use digital twin technology for high-value components and coupling that with federated learning.
And that's vital, right? Because federated learning lets different organizations collaboratively train AI models on risk or performance.
Without ever sharing their sensitive raw data. That's the key. Their proprietary data stays local on their own servers, but the collective intelligence of the model improves for everyone.
So you share the knowledge, but you don't share the secrets.
Exactly. They also plan to implement blockchain protocols to automatically detect IP or patent conflicts between shared designs. The system could instantly trigger pre-agreed negotiation processes or royalty payments. It automates trust and compensation.
And what happens midterm, by 2035, when the system gets more autonomous?
By 2035, the R&D ecosystem matures towards full autonomy. We see the introduction of specialized AI agents that act as R&D brokers. These intelligent software agents will facilitate autonomous negotiation for resource transactions, whether that's leasing computing power, transferring rights to test data, or brokering patent usage.
And the computing itself gets an upgrade.
A huge one. The report anticipates applying quantum classical hybrid computing. This means using the incredible speed of quantum computing for specialized subtasks alongside traditional processors to significantly accelerate complex physics-based simulations that are currently the biggest bottlenecks in R&D.
Which brings us to the ultimate 2040 goal for resource sharing. This is arguably the most radical and futuristic claim in the entire report. It really pushes the boundaries of co-creation.
It is the ultimate fusion. It's about establishing a technology base that uses neuromorphic computing coupled with brain-computer interfaces, or BCI. The vision isn't just about sharing data anymore. It's about capturing and sharing human creativity itself. The stated goal is to convert brainwave signals directly into engineering parameters.
I have to pause you there. BCI. Are we seriously talking about researchers plugging themselves into the design system?
Think of it this way. Instead of a designer spending weeks trying to translate a complex, nascent creative concept into CAD drawings or lines of code, researchers could use specialized neural interface devices, BCI technology, to share those raw thought patterns and creative concepts instantly.
And the AI does the rest.
The AI, using those neuromorphic chips that are designed to mimic the human brain's architecture, would then synthesize the optimal design solution from that collective intellectual pool. This is the literal meaning of co-creation sharing, the very essence of human thought.
Converting pure human thought into immediate digital design specifications. I mean, that level of efficiency would absolutely justify a 40% cost reduction in R&D.
It creates a true ecosystem brain, where human insight and AI speed are perfectly and seamlessly fused.
Okay, let's bring it back to the present just a bit. Let's talk about the final element of this pillar. Hardware-software collaborative design. This has to reconcile that fundamental conflict in the software-defined vehicle. Software iterates in weeks, but hardware cycles take years.
The goal for reconciling that by 2040 is complete hardware decoupling.
Okay.
Hardware has to transition from being proprietary, fixed components to being standardized, modular, abstract, and unified in its design.
It has to be plug and play.
Plug and play, allowing for easy replacement or upgrade, and crucially, it has to be cross-domain callable.
What does that cross-domain callable abstract layer actually mean for the hardware of a car?
It means that the computing power of a chip is abstracted away from the physical chip itself. The computing capacity can be dynamically shared across completely different functional domains in the car. For example, if the car is on a highway using Advanced Driver Assistance Systems, or ADS, the system might temporarily divert compute capacity from the entertainment system to the ADS module, all through software control.
So the hardware becomes a dynamic resource pool, not a set of fixed silos.
Exactly. And this entire hardware-software design life cycle, from selecting the raw material all the way through over-the-air or OTA upgrades, has to become a single, self-learning, self-iterating, closed loop.
Okay, moving to the intelligent supply pillar. The future factory and logistics system that's described here. It sounds far more like a high-tech, self-healing organism than traditional manufacturing. What are some of the high-tech highlights that ensure this, near-zero error, instantaneous delivery?
The key strategic move here is the transition from simple data visibility to what the report calls full process online sensing that enables autonomous execution. So by 2030, the foundation is being laid. You have real-time data collection from every point in the chain, AI being used for early exception detection, spotting equipment faults, quality issues, logistics delays, and the initial use of blockchain for secure, unalterable tracing of high-value parts like batteries and specialized chips.
But the real quantum leap in capability, that happens between 2035 and 2040. That's the drive toward global optimality.
Absolutely. By 2040, the system is fully data-driven with closed-loop autonomous decision-making. Digital twins, those virtual real-time replicas, they don't just cover factory floors anymore. They cover most of the extended supply chain. And most significantly, quantum computing is expected to achieve breakthroughs in solving massive logistical problems.
What kind of impossible problems are we talking about here?
Well, today's classical computers, they just can't efficiently solve problems like superscale, nonlinear dynamic supply chain optimization for global optimality. The number of variables is just too complex and numerous. It's an intractable problem.
But quantum computing can handle it.
Quantum computing, by leveraging principles like superposition, is expected to provide the raw computational power needed to achieve a globally optimal solution in real time. This allows the system to automatically detect a fault, say, a quality defect in a Tier 2 factory, and then immediately trigger self-healing processes across the entire global network without needing any human input.
And that capability for instantaneous global optimization translates directly into the next part. full chain accurate delivery, or the evolution of logistics. We're moving from human drivers to fully autonomous delivery by the midterm.
That's right. By 2035, automation becomes mainstream in logistics. You have autonomous trucks handling the long-haul shipments and drones managing specialized last-mile or urgent deliveries for critical components. But the 2040 vision, again, pushes the boundaries into the realm of metaverse logistics.
Metaverse logistics. How does a virtual environment coordinate the movement of physical goods?
The report suggests a highly virtualized and decentralized system. A production manager or even a customer places an order or triggers a demand signal inside a metaverse platform. This virtual command then autonomously triggers the physical execution system.
And the crucial factor enabling this zero latency control
Is the physical execution layer, which relies on instantaneous quantum entanglement-based inventory synchronization across global distributed warehousing networks.
Wait, I have to stop you again there because that phrase, quantum entanglement-based inventory synchronization, that sounds like pure science fiction. Are they really implying zero latency data transfer based on the principles of quantum physics?
That is the technical detail cited in the roadmap, yes. I know it's radical, but the core strategic idea is actually simple. Achieve zero latency data transfer. So the status of an inventory item, whether a critical chip is on a shelf in a warehouse in Germany or in Southeast Asia, is updated instantaneously across the entire global network.
Making the system truly real-time and fully synchronized.
Exactly. And this instantaneous visibility, when coupled with smart contracts, will auto-execute storage and transport tasks. It ultimately achieves that fusion goal where delivery becomes effectively just an extension of manufacturing.
So logistics becomes this single, real-time, zero-latency system managed by digital contracts and near-perfect data.
And the culmination of all of this is the final pillar, AI empowerment creating a global brain. This is what links all the disparate pieces together by 2040 into one collective intelligent organism.
How is this global brain structured?
By 2040, the intention is for AI to create a global brain neural network. The entire ecosystem, suppliers, OEMs, logistics hubs, researchers, is linked via those neuromorphic chips we mentioned earlier, forming a kind of conscious collective organism. And this system uses advanced temporal and spatial AI models to perform deep, proactive, predictive analysis.
Can you give me a concrete example of that proactive analysis? What does that look like?
Okay, so the system could, based on geopolitical risk indicators, climate data, and economic trends, predict the likelihood of a regional conflict or a trade disruption with a very high degree of certainty. And then, this is the critical part, it doesn't wait for human approval. It automatically switches production capacity to a different global factory proactively. It reroutes supply lines and adjusts production schedules across multiple tiers before the disruption even begins.
So data sharing and business collaboration become highly synergistic, intelligent, and self-managed from the ground up.
Yes, all driven by AI's continuous optimization loops.
This entire roadmap, spanning the 4 pillars and these quantified, decades-long milestones, it's just a stunning strategic vision. It really does suggest that the automotive industry is attempting to move from just managing a supply chain to nurturing a conscious, self-evolving technical entity.
That is the perfect high-level synthesis of it all. The entire roadmap is about moving the D&iSH from a functional, responsive system to a self-evolving, intelligent life form that's capable of autonomous decision-making and continuous value creation. It's a fundamental gene reassembly.
So what does this all mean for us, for you listening? What are the ultimate implications of the industry actually reaching this 2040 maturity level?
Well, the ultimate outcome, the completion of this gene reconstruction, is that it yields high resilience, the ability to withstand any shock and recover instantly, and this highly intelligent collaborative wisdom. The strategic focus permanently shifts beyond just traditional cost efficiency to the comprehensive optimization of the entire value stream.
So you're maximizing innovation speed, perfecting the customer experience, ensuring long-term sustainability.
All of it, the whole package.
And that emphasis on customer experience ties directly into the provocative thought that the report leaves us with. It concerns the very end of the car's life cycle, collaborative after-sales service in 2040.
Yes. And just think about the massive philosophical shift here. The system moves away from the traditional analog fault response model.
Yeah.
Your car breaks, you take it to the mechanic.
Right.
Instead, it moves to absolute prevention and foresight. The intermediate step is achieving near zero fault mileage by predicting maintenance needs based on real-time vehicle sensor data and scheduling maintenance moments before a part failure is even imminent.
But the report doesn't stop at vehicle sensor data for this kind of prevention. What is the truly ultimate preventative state that they describe?
Indeed. The final, most personalized step suggests that this predictive service will ultimately utilize brainwave and DNA data,
Brainwave and DNA data.
meaning data derived from the user's specific biology and their personalized driving intent to tailor maintenance and repair protocols. The system is maintained based on the user's specific requirements and usage patterns before any physical or mechanical problem even manifests. The supply chain becomes predictive, intuitive, and deeply personalized. It anticipates vehicle wear based on the very human who is operating the machine. That is the final frontier of integrated value creation.